Okay, one other thing is because some of the firewall rules have to do with allowing SSH on our host, or excuse me, on the server side. So we want to make sure that SSH is enabled on the server side to be able to test it. We can't test to see if a protocol it works if it doesn't even exist on the server. So this is Kali, and what we're going to do is we first check on the SSH status, which is why we're using. Sorry about this. I'm trying to focus on this, but it's not letting me. But anyways, we have sudo system ctl status ssh, and I do a no pager, so it doesn't. We don't have to press quit or anything, and we can see. And I'm happy we checked the status because even though it is installed, it is inactive. Probably because due to the defaults of Kali, but thankfully, most Kali distributions are going to come with SSH installed. So all we have to do is we do sudo systemctl restart SSH, and then we can check on the status, and we see now that it is active and running. And here is the log of the status of port 22 or SSH, and we do a little test ssh-l JSON. That's for the user, and -l is actually short for login or login name. So you determine who you want to log in as, and that would determine the SSH key that is transferred between server and client. So I'm just logging in as myself, and this is the IP address. And then it's does the one-time key share, and it actually sends a SHA-256 fingerprint. And in order for you to even accept the connection, you have to accept the fingerprint. And moving on, every time you log into SSH, it does the certificate check because the fingerprint acts like an external fingerprint, like actually like a private key. And if your private key, so this fingerprint is kind of like it's kind of like a summarized version of a private key. And if the private key if these private keys don't match, meaning your fingerprint on the client and the fingerprint offered by the host, if they do not match, it will actually say, hey, you've been a victim of the man in the middle attack. That's why SSH is, much better than Telnet. Also, the if you do a Wireshark packet sniffer, you will see an encrypted connection. And so that being said, I don't mean to regurgitate things you already know, but we're proving that at least we can SSH into the remote system. Now, I don't show what do you do when you're done, because at some point you want to go ahead and test. You want to create the UFW firewall rules on the server, and then you want to test it with this Ubuntu, but you can't very well test it while you're inside the SSH tunnel, if you will. So the idea here to get out of this SSH session, you have to type in EXIT for exit. That will exit the session. Now, we're going to configure the firewall on Kali. So you just copy and paste or just type this in. And you're going to wind up, if you do a sudo UFW status numbered verbose, you're going to wind up with something like this, which will show all the rules that you were able to change. And then you're going to verify the final policy. You're going to ping, and this does ping the Kali IP. And then you're going to do FTP, and you can see, although it is able to ping, we do the ping dash n, and actually that was wrong. It's actually I had to do a man page lookup for ping, and I realized that, hey, I had to do a ping dash c for, so the c stands for count, and it pings it 4 times. And sometimes I got a little confused. Dash N is the same thing as dash C, but dash N is for Windows. And anyways, I made a mistake, so it's ping dash C 4 that pings the remote server 4 times, and just to make sure it's able to ping, but we cannot utilize FTP because when we tried to FTP, it says connection timed out, and then it says can't connect to 192.168.214 colon FTP. Okay, which kind of coincides with the rule that we created. So we have successfully applied the UFW rule to prevent somebody FTPing, but yet we're still able to ping the location.